Good morning, grade sixes. So like I told you last week, we are moving on to a new strand in math. We are going to be stepping back into some geometry. We're going to be looking at solid geometry, three-dimensional geometry. And this video is going to focus on the difference between volume and surface area because I have been teaching long enough to know that kids get these two things confused all the time, so I really want to make sure that you guys are 200% clear on what those two things mean and why they're different. This is a review. You guys have learned volume and surface area before, but you have not used triangular prisms. You've done it with rectangular-based prisms. It's the same concept. It's just going to be a slightly different formula. So before we move on to what is surface area, let's talk about what is volume. Looking at this blue prism up at the top corner, if I was talking about volume, I would be talking about the amount of space that this prism takes up. We measure liquid in volume. If I were to fill this prism from the base all the way up to the top. So imagine, I picked the blue one because I thought it would be easy to imagine. Imagine that it's filled with water from the bottom to the top. This right here would be a representation of volume. How much space is in that prism? Now, for this video, we are not looking at the volume yet. So I'm just going to cross that right off. We are going to be looking at surface area. Surface area has a magic word that should make the light bulb go off right away because you guys know what area is. And when you see area in the words surface area, you should be going ding, ding, ding. This is a square unit measurement. It is a flat measurement. Area is a flat measurement. When we did our two-dimensional geometry unit, we explored squares, rectangles, triangles, and the big idea there was understanding the difference between perimeter and area. Perimeter being a linear measurement where, you know, if I was a little ant and I was walking around the outside of my triangle here, how far did the tiny ant walk? Well, that's a linear measurement. It's a line, there's a couple bends in it, but I would measure that in linear units, linear centimeters, millimeters, kilometers, meters, whatever. Then we got into area, where you guys told me area is the flat space inside of that two-dimensional shape, and we got that by using squared units. So centimeters squared, millimeters squared, meters squared. So surface area, it's two-dimensional. But miss, these are three-dimensional objects. Yes, they are, but those three-dimensional objects, you may remember from previous years, can be decomposed into their flat surfaces. They can be decomposed into nets, which I will be posting a link to on Edsby. So I want you to take a look at this orange triangle down at the bottom here, and let's look at this orange triangle in terms of surface area. If I wanted to calculate the surface area of this triangular-based prism, I would have to notice that it's made up of faces. So like this face right here that I'm coloring in is a rectangle. Well, you know what? You know how to find the area of a rectangle. So if I found the area of that right there, and then I went, okay, but there are other faces here. Oh, look, there's a triangular face. Well, I know how to find the area of a triangle too. So I could calculate the area of that. And then you may also notice that there are more faces. So there's a face on the bottom. There's a face on the back. There's a face on the side. If I add all of those faces up, all of those squared unit measurements up, I'm going to end up with the surface area that this triangular-based prism would have. Surface area is wrapping a present and needing to know how much gift wrap you need to buy. Gift wrap is flat, but the present is three-dimensional, and you need to cover all of its sides. Surface area is painting. You know, I'm painting my bedroom. I've got 4 walls and a ceiling. It's not like I'm going to pour paint into my bedroom until it is full from the floor to the ceiling. I'm going to just paint the walls, and I need to know how much paint I need to buy. That's where you use surface area. So before we get onto another video where we talk about volume, let's actually practice calculating some surface area. I have a triangular-based prism over here with some measurements on it that we should be able to use to calculate our surface area. So again, looking at this triangular-based prism, we're going to kick it all the way back to grade 1, where you guys learned about how many faces do geometric solids have. And you may remember or you may count, but triangular-based prisms have 5 sides. there are 5 faces, excuse me, not sides. There are 5 faces. So I know that I have to calculate the area for all 5 faces. I'm going to label these faces. So we're going to say this one's going to be A, the one on the back is going to be B, the one on the bottom is going to be C, and then this one here, I'm going to point to the one on the triangle here, I'm going to call that T for triangle. So I'm going to make sure that I get all of those calculated, and then I'm going to add them all up. So let's start off with the surface area of A, which is this face right here. So A, calculating the surface area for A would be, it's a rectangle, so it's just base times height. My base of 5 units, and it's got a height of also 5 units. You can see that all of these are equal. All of those side lengths are equal. So 5 times 5 is going to give me, it's going to give me a measurement of 25 units squared. So that right there is for one face. Now let's calculate B. So B is this rectangle along the back side. What are the dimensions? You can see that it is 2 units by 5 units. So I'm going to do that. I've got 2 units times 5 units, and that is going to give me 10 units squared. Beautiful. Now, the bottom rectangle, this one right here, rectangle C. Let's calculate that. Rectangle C, Rectangle C has got dimensions of 4 by 5 units. So I'm going to go 4 units times 5 units, and that is going to give me a total of 20 units times units is units squared. So far what I've done is I've gotten the surface area of all of the rectangles in this prism, and the last thing you might be noticing is there are triangles. These 2 triangles here are congruent. They are the same size, shape, they're identical. So really all I have to do is calculate the surface area for one and double it. So calculating the surface area for triangle is going to be, if you remember the formula, it's always base times height divided by 2. Well, that's going to give me, so my base is 4 units, my height is 2 units, so 4 times 2 divided by 2. And if I calculate that, 4 times 2 is 8, divided by 2 is 4. 4 units squared. I do need to have 2 of those though. So this one right here, I want to make sure that I double it. Okay, so the final step here is to add all of this stuff up. So the surface area for this particular triangular base prism is going to be, so surface area is going to be equal to the area of side A plus the area of side B plus the area of side C plus the area of T, but times 2. And I'm going to do that. So surface area is going to be A, 25 units plus 10 units plus 20 units plus triangle times 2 would give me 8 units. And, all of those are squared. And finally, the surface area. 25 plus 10 is 35, 35 plus 20 is 55, and 55 plus 8 is going to give me 63 units squared, and that is the surface area of triangular prism up in the corner there. Okay, guys, hopefully that was helpful.